Hello guys, in this present session we are going to see how to read a drawing, particularly the architectural and structural drawings, and we are going to cover the column layout, footing layout, and how to read a plinth beam drawing today. Okay, so is it really necessary for a site engineer to understand how he has to read the drawing? Yes, it is very important because as a site engineer we are taking a lot of responsibilities on the site, like marking. The first and the foremost thing, if we don't know how to read a structural drawing and an architectural drawing in the beginning stage itself, it is very difficult to set up any kind of drawing onto the site actually. So first and the foremost thing is we should understand what exactly the things we have to read in a drawing and how to get it understood as a site engineer. Okay, the first and the foremost thing is we are going to get the architectural drawing. This is how the architectural drawing will look like. The architecture drawing, we are going to refer it during the wall construction mainly. When we are going to start the wall construction, we are going to refer the architectural drawing. So in the architectural drawing, the most important thing, they have shown you where exactly the wall is coming, where exactly the windows are coming, windows W1, W2, W3, door D1, D2, D3, and all those things. There are a lot of informations. We have to collect it from the architect. That is, what is the sill level, what is the lintel level, and what is the width, what is the length, what is the height, what is the thickness of the wall. All those things has to be provided by an architect to the site engineer. So these details we are going to collect it from an architect. You can see here, this is the ground floor plan, this is the entry of the house. We are having 3 steps. For example, each step, if you take the riser as 6 inches, so 3 steps, it's almost 1 feet 6 inches. So if I, by this drawing, what I'm understanding is my floor level is 1 feet 6 inches above the parking level. So this is what I'm getting a basic information from the drawing. This is the main door is there. MD represents the main door. So when I come here, if I want to take the dimension, I'll just see how much is the wall thickness. It is 230 mm or 9 inches thick wall. So they have given some basic furniture layout and all here. So this is the ground floor plan and this is the first floor. If you observe very carefully, you can see here the column layout. The column has been provided in the architectural drawing. Okay, this is the column which has been given in the architectural drawing, overlapped onto the architectural drawing, the columns. So I can see both the architectural drawing as well as the column position on the plan, architectural plan, where exactly the column has been located. This is the basic information I'm telling. We are going to the advanced level in the upcoming parts. Okay, this is the first floor plan. I'm going to climb the steps here. Coming back here, this is the first floor. This is the cutout. This into mark represents the cutout. This is a small projection is there. So these some information we are getting in the first floor. But today's agenda is how to read a structural drawing. So in reading a structural drawing, the first one is the column layout. So when you go to any kind of drawing, okay, you will be having a box here. This is called as the description box, title box. Lot of names you can give it to this particular box. So here in this box, the first and the foremost thing what you have to see is the job number. That is, job number represents every project will be having a number. For example, 2020 P28, that represents in the year 2020 the project number is 28. If tomorrow some changes has to be done, okay, we cannot always remember the client name. The client is Mr. Raghavendra. He is from Tumkur. Okay, the architect is Jayamiti Architects from Bangalore. I am providing the structural details for them from past 8-9 years. Okay, so the job number is 2020 P28. So there is the first and the foremost thing, as a site engineer, we should be knowing the job number. When we give a call to the architect, we can just refer them. This is a job number we are actually quoted on our structure drawing. Please refer to this and give me certain details. If you require any details, you can just give this job number. Next, there will be sheet numbers. Sheet number 1 to 3 means there are 3 sheets total in this particular structure drawing 1. So I am referring to the sheet number 1. So the title of the drawing is column layout. The date will be there. The scale, not to scale, or if the scale is there, they will mention it. That whatever the client name is there, they're going to mention it here. And the revision, it is very, very important. How many revisions had been made, and you have to mention. It has to be confirmed with the architect as well as the structural engineer what exactly the final revision has been happened and which drawing we have to take it onto the site. And the most important thing is purpose. Here the purpose may be for approval, for discussion, for execution. So only the drawings which has been mentioned as for execution or good for approval or good for execution seal on it, only those drawings you have to refer it onto the site. Next, the architect is this. Structural consultants, we, the money, the business services are the structural consultants. And the notes, very, very important. Here, the notes will be the grade of the concrete they will give. Here you can see M20 grade, Fe 500 steel we have to use. The cover for the footing should be 2 inches. The cover for the column should be 1 inches. Read this drawing along with the relevant architecture drawing. Here, this is the very, very important. This is what I was about to tell you. Like the job number, what we have referred, even the architect should be having their job number. We will be reading this structural drawing along with the relevant architecture drawing. So this drawing has to be referred only with respect to this architectural drawing only, not with respect to any other drawings. Okay, so relevant architectural drawing. Then provide number of chairs and covers. These are the general specifications we are going to give it. SBC of the soil is this. How we got the SBC of soil as per the information. Building is designed for ground. This is not important as a site engineer. Once the drawing comes to your hand, the first and the foremost thing is you should see to it what is the width and depth of the site. The width of the site is 45 feet and the depth of the site is 64 feet 6 inches. So we should understand what is the width and depth of the site. Once we get this on the site, what we have to do is we have to check this diagonal dimensions properly on the site. I'm going to show you one more drawing now. The diagonal dimensions with respect to the site, we have to check it because on the drawing it is exactly rectangle, but on the site we have to cross verify this. If we are finding any kind of discrepancies or any kind of what we call changes here, we have to brought to the notice of the structural engineer as well as the architect. Here they have shown a rectangle, it is exactly the same. I'll show you one more drawing later where the dimensions is totally different. I'll just show it to you now itself. One second. See here. So in this particular drawing, observe here, the site is almost inclined. Can you see here? It's almost inclined. But the first drawing, whatever they have given it, I'll just show you to you. The first drawing, whatever we have done it for the client was like this. It was like this. Can you see here? I'll just layer off. I'll just show you to you that client has given like this. The client has given like this. This was the client given, but actually the site was like this. Can you see here? This was the client provided this one. This information has been provided by the client for us. But when we actually measure it on the site and when we take up the diagonal information, this was actually wrong. This was the correct proper dimensions. Here the inclined dimensions are totally different. Can you see here? This is almost 58 feet 5 inches. And here it is 53 feet 4 inches. So as a site engineer, it is very, very important to understand the diagonal dimensions on the site. That is the first and the foremost thing. As a site engineer, you have to do it, and it has to be brought to the notice of the architect as well as the structural engineer immediately. Okay. Next, when you are going to the site, you have to see the grid lines. They have given A, B, C, D, E, F, G, H, and 1, 2, 3, 4. So why the grids are very important? Because why the grids are important? Because, for example, if you are having any problem in setting up a column or setting up a foundation, you cannot tell them in this line or in this part, northeast, north, south, you cannot tell it. If you represent it with respect to the grid line, for example, if I am having a problem in setting up this column due to some conditions, site conditions, some problem. So what I can tell them? I can tell them with respect to grid 6 and D6. So I can tell them with respect to D6, the column, whatever is there, C3, square column, we are finding so and so difficulties. So I am bringing it to the notice of you people. This is how you have to communicate. So grid lines from the beginning till the end of the projects are very, very important. So you have to represent and you have to communicate with the structural engineer or the civil engineer or any architect with respect to grid lines. So when you are telling with respect to grid lines, it is easy for you to communicate with them and you can solve the problem immediately. So when you are reading any kind of column layout, this is the first thing. The column sizes is important. They have mentioned C1, C2, C3 and all. This comes the next one. It's very important. But before that, the grid lines are there. Okay, you have verified the diagonal dimension. It is correct. So site dimensions also you have to check it out. 64, 6 inches, 45. It is also correct. Then what you have to do? You are going to do the marking. So marking, you are going to start from any point. You are going to put a perpendicular here. and you're going to start putting the horizontal and vertical lines on the side, maybe you can use the conventional method of using the metal rods, MS rods and the thread, or you can use the total station equipment also. So once all these points are laid, so you have to place the column. So what are the different information you have to take it with respect to the column? The first one is how the column is positioned with respect to this grid lines. The column is positioned with respect to the grid line like this. That is, it is positioned vertically 4.5 inches, horizontally also 4.5 inches like this. This is the important thing. So how exactly you are actually placing the column onto the side, this is how you have to place it. Okay, 4.5 inches with respect to this, 4.5 inches with respect to this. This is the finishing dimension. Please understand here, this is the finishing dimension you are giving. I'll show you the cross section of the column, how the details has been given. This is the C1 column. We are referring to C2 column. Okay, C2 column, observe here, there is 15 inches by 9 inches. Okay, you have to leave the cover, that is 1 inches cover will be there, or 25 mm we can tell it, or 30 mm we can tell it with respect to the column. So that cover up, when it is finished, it will be 9 inches by 15 inches. So when you are placing the column here on the side, with respect to the reinforcement, you leave 1 inches gap, so that when you are put the concrete onto the using the column box, it will be adjusted. So the first one is the side dimension. Second is the diagonal dimensions are very, very important. Third one, you are laying the reading how to read the grid lines, where A1, A2, D1, D2, all those things, grid line, and how to communicate with the architect or structural engineer with respect to the grid lines. Next point is the column dimensions and how the columns has been placed. What is the dimension with respect to horizontal and what is the dimension with respect to the vertical. This is about the column layout. And the next thing is here in the column layout, the dimension that has been given with in between the grids. It's very important, in between the grids, and with respect to the boundary of the site. With respect to the boundary of the site, how much is the distance has been given. So all these informations are, to read all these informations, it is very essential for a site engineer, because if we don't know to read all this information, we cannot set up anything on the site. So what we are learning as a site engineer, working as a site engineer, I learn how to read the drawings. Okay, if I know how to read the drawings, tomorrow when I'm going to set up my own consultancy, at that time I'm not finding any kind of difficulties. I can directly take up the drawing and execute it onto the site. Got it? Next we'll go to the footing layout. So in the foundation layout, again the same title box, you can see the title foundation layout. See the drawing number, it is second drawing with respect to third, and all other details will remain same. You have to just cross verify revision 3, drawing number and all those things, that will be same. Once these lines has been laid on the site, then what you have to do, for example, I take the same example. When you are actually plotting this box on the site, okay, with respect to the grid line only you have to do it. Again, the grid lines are coming into the picture. Please observe here, I have to mark it. For example, I have to mark this line 2 feet from this and 2 feet 6 inches, so that the column is exactly on the center. Observe here, the center line of the column and the center line of the footing has to meet each other. See here, so the column has to be placed exactly on the mid of the foundation. So this is what we have to see to it. So the structural engineer will give you with respect to the grid lines, they will mark everything. You just cross verify it whether this column is exactly placed. For example, this is 2 feet 3 inches, and also from center this is 2 feet 3 inches. So the column will be exactly stood at the center of the foundation. So with respect to the foundation, the width and the depth of the foundation, length and width of the foundations are very, very important. Generally, the length and the width of the foundations are given at a difference of 6 inches. Generally, it is a practice. Okay, rectangular foundation. Square foundation, it will be like equal dimensions. For a circular column, we provide the square footing itself. Generally, rectangular circular foundation are not provided on the site. Okay, like that, if you observe, all the columns will be having with respect to the grid lines, what is the dimension onto the left, right, top, and to the bottom. When I come to the detailing part of it, what are the details? I'll get it. If I take foundation F1, foundation size is 5 feet by 4 feet 6 inches. Depth, this D represents depth of the concrete. Can you see here? I'll show you the cross section of the foundation, typical cross section of a footing. D represents the depth of the foundation. PCC we have already learned in the previous part 1. If you have not seen that video, please go to it in the playlist. It is there, site engineer part 1. You just see to it what is the importance of PCC. So the PCC we are going to lay it, then the depth. So the minimum for any kind of residential building, ground plus first floor or ground plus second floor, depending upon the soil condition, the soil report, they are going to suggest what should be the depth of the foundation from the floor level. Here it is the floor level. It should be ground floor level. From the ground floor or the existing floor level or the natural floor level, we have to go minimum of the minimum 5 feet. Okay. On the 5 feet, we are going to lay the PCC of 4 inches or 6 inches as per the requirement. Then this D represents the depth of the concrete which we have to put it. And they'll give you the sizes of the shorter dimension and the longer dimension. Always remember, the shorter dimension reinforcement has to be laid first, then the longer dimension reinforcement, that is the distribution reinforcement, has to be laid onto it. Got it? So if this is the thing, the bottom rod should be the shorter dimension. Can you see here? Shorter reinforcement. Here the longer reinforcement has to be laid onto it. Okay. This information will get it. If you see this is the shorter dimension, shorter reinforcement on the shorter direction, longer reinforcement on the longer direction. This is how the column has been put it. This is the eccentric footing, which we will discuss it in detail in the upcoming sessions. Okay. The grade of the concrete is given as M25. If I go to the column again, they have given it what do we call this as a hatch kind of thing, half hatch. 6 rods are there, 16 mm, 9 inches by 15 inches. The ring size is 8 at 6 inches. The column size is 9 by 15 inches. So these are all some of the basic information what I'm telling you, which as a site engineer, we should know to it. Okay. Then comes to the plinth beam drawing. The plinth beam drawing has to be read along with the architectural ground floor plan. Why the ground floor? Because ground floor, the wall, whatever it is there, it will be resting on the plinth beam. Therefore, we have to check, cross check 1 time, 2 time, 3 time, correlate both the drawings and see to it whether whatever the beams has been given are in line with the walls has been given by the architect, and the structural engineers are same. I think you are understanding what I'm telling you. I'll just show it to you. If I'm going to overlap this, I'll just layer up this. Just overlap this to this. If you observe here, I can see these yellow lines. Okay. Can you see here? It is actually missing. This wall is coming outside and this beam is inside. To show this difference, intentionally have done this. Okay. So that we can understand what is the problem happening on the drawings and the site. So this we have to brought it to the notice of the, 1 second. This we have to brought it to the notice of the architect and the structural engineer. How we will bring it to the notice of the structural engineer? We will tell that in between grid 1 and 2, in between grid A and D or A and C, we are having a plinth beam PB2 at 6 feet 8 inches. It has been shifted. Please look into it and provide the proper details. This is what the comment we are going to do. That's it. Very simple. Then we'll just see any other, nothing. That's it. If you see any other, no. Everything is proper. So this is how we are going to do it. In the plinth beam drawing, again, the grid lines are very important to mention it. Then the depth of the foundation, depth, width and depth of the beam are very important. Sometimes they will give you a different depths. Okay. Here, top of the plinth beam will be to the top of the flooring level or 3 inches more or less depending upon the site execution. How we are going to do the execution, we are going to keep it. Generally, top of the plinth beam will be to the top of the ground floor, that is ground floor level. Okay. Plinth beam top will be to the ground floor level. And we have to see to it properly what should be the floor height with respect to the existing road level and all. With respect to that height only, we are going to do the plinth beam. So plinth beam rods also PB1, PB2, PB3, they'll give you all the details like 4 of 16, 2 of 12 is there, size of the foundation is there. This is the pier they have given, because nowadays we are not doing any kind of SSM work below the plinth beam. It was a conventional method. Previously was doing it, but now as it is a framework structure, all the loads will be taken by the plinth beam. But if we don't have any support kind of thing, we are going to provide a SSM pier here as a simply support to support this plinth beam. That's it. Okay. So this is about the session. If you are find any kind of doubts, you can just put it in the comment box. I am here to help you people. Thank you. We'll see in the part 3 with some very useful information with respect to the site. Thank you.